In the previous lecture, we discussed the how to calculate the total float, free float and independent float for a given network diagram. In this lecture, we will discuss the critical path method and we will solve the one example problem to find a critical path for a given network diagram. First, we will see the what is the critical activity. An activity is said to be critical if a delay in their execution will cause further delay in the project completion time. Which means if we are delaying the any activity, it causes the delay in the total project completion time. That respective activity we are calling as a critical activity. All activities having zero total float value are identified as critical activities. These critical activities are identifying by observing its total float value. For the critical activities, total float value is the 0. Next, critical path is the sequence of critical activities in a network. It determines the duration of a project is called the critical path. So critical path is the sequence of all the activities. And this critical path determines the duration of the project. And it is the longest path in the network. So critical path is the longest path from starting event to ending event. And it defines the minimum time required to complete the project. So critical path is the longest path and it is defined as the minimum time required to complete the project. In the network, it is denoted by a double line and identifies all the critical activities of the project. Hence, for all the activities to lie on the critical path, following conditions must be satisfied. First one is the ES of I equal to the LS of I. Second condition is the ES of J equal to the LF of J. Similarly, ES of J minus ES of I equal to LS of J minus LS of I equal to the Tij, which means so activities which are lies on the critical path. Here earliest start time equal to the latest finishing time of the I event. Similarly, earliest start time equal to the latest finishing time of the J event. And also differences between the earliest start time for the I event and J event equal to the so difference between the latest finishing time of the I event and the J event, and which is equal to the time activity. So following procedure is the to determine the critical path of the given network diagram. Step 1 is the list all the jobs and then draw a network diagram. First step is you have to draw a network diagram. Second step is indicate the normal time for each activity above the arrow, which is the deterministic. So after the draw the network diagram, we have to indicate the normal time for each activity on the above the arrow. Third step is you have to calculate the earliest start time and earliest finish time for each event and write as the earliest time EI. So here we are determining the earliest start time as well as the earliest finishing time for all the activities by using the forward pass computation, and here we are indicating the EI for all the events, and also have to calculate the latest finish time and latest start time by the backward pass computation method, and here writing as the so latest time, that is the LJ for each event. So next step 4 is the tabulate the various activities which are the normal time, earliest time and the latest time on the arrow diagram. So fourth step is you have to tabulate all the times. So next fifth step is you have to determine the total float for the each activity. So we know total float is the difference between the earliest start and the latest start time. Sixth step is the identify the critical activities and connect them with a beginning and the ending events in the network diagram by double line arrows. So this is used as a critical path. Step 7 is we have to calculate the total project duration. We will look for one example problem on this method to find a critical path. Let's see the problem. Here it is given the various activities and its time duration. Then draw an arrow diagram representing the project. Second one is the find the total float for each activity. Third one is the find the critical path and total project duration. Let's see the solution and we can solve it by step. So let's see the first step is the list all the jobs and then draw a network diagram. So here first step is we have to draw a network diagram for a given activities. First activity is the 1 to 2. So let's draw it 1 to 2 activity. Next we have to draw the activity 1 to 3. So from event 1 to we have to draw another activity, that is the 1 to 3. Next is activity 2 to 3 and 2 to 5. So from 2 to 3 you have to draw one activity. Already event 2 also there, 3 also there. Then you have to draw from 2 to 3. So this is the activity 2 to 3. Similarly you have to draw the 2 to 5. So this is the activity 2 to 5. Next we have to draw the 3 to 4, activity 3 to 4. So this is the activity 3 to 4. Similarly, you have to draw another activity from the 3, that is the activity 3 to 6. So this is the activity 3 to 6. Next, you have to draw the activity 4 to 5. So already event 4 also there, 5 also there. Then I have to draw the activity from 4 to 5. And next one is the 4 to 6. Already event 4 also there, 6 also there. Then you have to draw the activity 4 to 6. Next one is the 5 to 6. So from event 5 to event 6. Event 5 to 6. Another one is the activity 6 to 7. So this is the network diagram. Next we have to see the second step. Indicate the normal time for each activity above the arrow which is deterministic. Here it is given the time duration is the deterministic. Then we have to represent the each time duration on the above the arrow. First observe for the activity 1 to 2 time duration is 15. We have to represent the 15 on the above the arrow for activity 1 to 2. Similarly for the activity 1 to 3 it is the 15. Next to 2 to 3 it is the 3. Next one is the 3 to 4 it is the 8. Okay, so 3 to 4 8. And next one is the 2 to 5 it is the 5. And next one is the 3 to 6 it is the 12. And next one is the 4 to 5 it is 1. And 4 to 6 14. 5 to 6 3. And finally 6 to 7 is the 14. Third step is the calculate the earliest start time and the earliest finish time for the each event and represent the EI for each event I. Also I have to calculate the latest finish time and start time and represent the LJ for the each event J. So this is the network diagram. First we have to determine the earliest start time and finish time. First we have to start with the activity 1 to 2. So for activity 1 to 2, 1 is the starting event, then its earliest start time is the 0. And earliest finish time will become the 0 plus 15, that is the 15. Next we have to see the activity 1 to 3. So start time is the 0 for activity 1 to 3 and finish time will become the 0 plus 15, that is the 15. Here observe 3 merge event for the activities 1, 2, 3 and 2, 2, 3. Next we have to observe the activity 2, 2, 3. For activity 2, 2, 3 start time is the 15 and finish time will become the 15 plus 3, 18. So among the 18 and 15 we have to consider the maximum value, that is the 18. Next we have to look for the activity 2 to 5. So for activity 2 to 5 start time is the 15 and finish time will become the 15 plus 5, that is the 20. Here also observe that one the event 5 is the merge event for the activities 2 to 5 as well as the 4 to 5. So next we have to observe the activity 3 to 4. Start time is the 18 and finish time will become the 18 plus 8, that is the 26. And next we have to look for the activity 3 to 6. Start time is the 18 and finish time will become the 18 plus 12, that is the 30. Here also observe that one the event 6 is the merge event for the 3 to 6, activities 3 to 6 and activity 4 to 6 and activity 5 to 6. Next we have to look for the activity 4 to 5. So for activity 4 to 5 start time is the 26 and finish time will become the 27 plus 1, it is the 27. Among the 20 and 27 we have to consider the maximum value, that is the 27. Next we have to look for the activity 4 to 6. For activity 4 to 6 start time is the 26 and finish time will become the 26 plus 40, that is the 40. Next we have to look for the activity 5 to 6. Start time is the 27 for activity 5 to 6 and finish time will become the 27 plus 3, that is the 30. So among the 30, 40 and 30 we have to consider the maximum value, that is the 40. Next we have to look for the activity 6 to 7. Start time is the 40 and finish time will become the 40 plus 40, that is the 54. So next we have to determine the latest start time and the latest finish time by the backward pass computation. So here I have to start with the last event and we are considering the here latest finish time equal to the earliest finishing time, that is the at the event 7 latest finishing time is the 54. So latest start time will become the activity 6 to 7 will become the 54 minus 14 is the 40. So next we have to look for the activity 5 to 6. Finishing time is the 40 and start time will become the 40 minus 3, that is the 37. Next we have to look for the activity 4 to 5. For activity 4 to 5 finishing time will become the 37 and start time will become the 37 minus 1, that is the 36. Next we have to look for the activity 4 to 6. For activity 4 to 6 finishing time is the 40 and start time will become the 40 minus 14, it is the 26. So here observe that one the event 4 is the burst event for the activities 4 to 6 and 4 to 5. Among these two values 36 and 26 we have to consider the minimum value. In the backward pass computation method we have to consider the minimum value at the burst event. So latest start time at event 4 will become the 26. Next we have to look for the activity 3 to 6. 3 to 6 finish time is the 40, then 40 minus 12, 28. Start time is the 28. Here also observe that one the event 3 is the burst event for the activities 3 to 6 as well as the activity 3 to 4. Next we have to look for the activity 3 to 4. Start time, so latest finish time is the 26. Start time will become the 26 minus 8. It is the 18. So among the 18 and 28 we have to consider the minimum value is the 18. Next we have to look for the activity 2 to 3. Finish time is the 18. Start time will become the 18 minus 3, 15. And here also observe that one the event 2 to 5. So event 2 is the burst event for the activities 2 to 5 and the 2 to 3. So next we have to look for the activity 2 to 5. Finish time is the 37. Start time will become the 37 minus 5. Sorry, here it is the 32. So among the 32 and 37 we have to consider the, so 32 and 15 we have to consider the minimum value is the 50. Next we have to look for the activity 1 to 2. So 15 minus 0. Similarly I have to look for the activity 1 to 3, that is the 18 minus 3, 18 minus 15, that is the 3. So among the 0 and 3 we have to consider the minimum value is the 0. So here event 1 also burst event for the activities 1 to 2 and 1 to 3. So for this one 0 and 3 we have to consider the minimum value is the 0. Next step is the tabulate the various times, that is the normal time, earliest start time and earliest finish time, latest start time and latest finish time. First we have to write down the in the tabular column all the activities along with its normal time, and also have to write down the earliest start time and earliest finish time, and also write down the latest start time and latest finish time. Here we note down the earliest start time and latest finish time by observing the network diagram. First we have to note down the earliest start time by observing the network diagram. First one is the activity 1 to 2. For activity 1 to 2, earliest start time is the 0 at event 1. And next one is the activity 1 to 3. For activity 1 to 3, earliest start time is the 0 at event 1. And next one is the activity 2 to 3. For activity 2 to 3, earliest start time is the 15 at event 2. Next activity is the 2 to 5. For activity 2 to 5, earliest start time is the 15 at event 2. Next activity 3 to 4. For activity 3 to 4, earliest start time is the 18 at event 3. And next one is the activity 3 to 6. For activity 3 to 6, earliest start time is at event 3, that is the 18. Next activity 4 to 5. For activity 4 to 5, earliest start time is the 26 at event 4. Next one is the activity 4 to 6. For activity 4 to 6, earliest start time is the 26 at event 4. Next activity 5 to 6. For activity 5 to 6, earliest start time is the 27 at event 5. Next one is the activity 6 to 7. For activity 6 to 7, earliest start time is the 40 at event 6. So next we have to note down the latest finish time by observing the all the activities. First one is the activity 1 to 2. For activity 1 to 2, latest finish time, it will equal to the 15 at event 2. And for activity 1 to 3, latest finish time is the 18 at event 3. Next one is the activity 2 to 3. For activity 2 to 3, latest finish time is the 18 at event 3. Next one is the activity 2 to 5. For activity 2 to 5, latest finish time is the 37 at the event 5. And next one is the activity 3 to 4. For activity 3 to 4, latest finish time is the 26 at event 4. Next one is the activity 3 to 6. For activity 3 to 6, latest finish time is the 40 at event 6. And next one is the activity 4 to 5. For activity 4 to 5, latest finish time is the 37 at event 5. And next one is the activity 4 to 6. For activity 4 to 6, latest finish time is the 40 at event 6. And next one is the activity 5 to 6. For activity 5 to 6 also, latest finish time is the 40 at the event 6. And last one is the activity 6 to 7. For activity 6 to 7, latest finish time is the 54 at the event 7. So after observing the earliest start time and latest finish time by observing the network diagram, then you have to calculate the earliest finish time and the latest start time. Earliest finish time is the earliest start time plus activity time. For activity 1 to 2, earliest start time is the 0 and normal time is the 15. Then earliest finish time is the 0 plus 15, that is the 15. Next for the activity 1 to 3, that is the earliest start time is the 0 and normal time is the 15. So 0 plus 15 is the 15. And for activity 2 to 3, 3 plus 15, that is the 18. And next activity 2 to 5, 5 plus 15, that is 20. Next for the activity 3 to 4, 18 plus 8, that is the 26. Next for activity 3 to 6, 18 plus 12, that is 30. Next activity 4 to 5, 26 plus 1, that is 27. Next activity 4 to 6, that is the 26 plus 14, that is 40. Next activity is the 5 to 6 for this one, 27 plus 3, that is the 30. And final activity is the 6 to 7 for this one, 40 plus 14, that is the 54. Similarly, we calculate the latest start time for this one, latest finish time minus normal time, that is activity time for the activity. So latest start time will become the latest finish time LF minus normal time, that is the TIJ. For activity 1 to 2, latest finish time is the 15 and the time normal time is also 15, that is the 15 minus 15, it is the 0. Next for activity 1 to 3, so latest finish time is the 18 and normal time TIJ is the 15, that is 18 minus 15, it is the 3. For activity 2 to 3, 18 minus 3, it is the 15. Next one 37 minus 5, that is the 32. And next one is the 26 minus 8, that is the 18. And next activity 3 to 6. So latest finish time is the 40 and the normal time is the 12. Then 40 minus 12, it will become the 28. And next activity 4 to 5, 37 minus 1, it will become the 36. Next for activity 4 to 6, latest finish time is the 40 and normal time is the 14. Then 40 minus 14, it is the 26. Next activity 5 to 6, that is 40 minus 3, it will become the 37. And activity 6 to 7, latest finish time is the 54 and the normal time is the 14. Then 54 minus 14, it will become the 40. Next step 5 is the determine the total float for each activity by taking the difference between the earliest start time and the latest start time. First observe the total float for the activity 1 to 2. That is the latest start time LS minus ES, earliest start time. For activity 1 to 2, latest start time is 0 and earliest start time also 0. Then 0 minus 0, it will become the 0. And next activity 1 to 3, 3 minus 0, it is the 3. And next activity 2 to 3, 15 minus 15, it is also 0. Next activity 2 to 5, so it is the 32 minus 15, it is the 17. Next activity 3 to 4, 18 minus 18, it is the 0. Next one is the 3 to 6. For that one 28 minus 18, it is the 10. Next activity 4 to 5, that is the 36 minus 26, it will come the value 10. Next activity is the 4 to 6. For 4 to 6, it is the 26 minus 26, it is the 0. Next activity 5 to 6. For this one 37 minus 27, it is the 10. And last activity is the 6 to 7. For this one, latest start time LS is the 40 and also ES also 40. Then 40 minus 40, it is 0. So next step is we have to identify the critical activities. What do you mean by critical activities? So the activity which having the total float is the 0. Here for activity 1 to 2 total float is 0 and activity 2 to 3 also total float is 0. Next activity 3 to 4 is total float is 0 and moreover for activity 4 to 6 also it is the 0. Sorry, here it is missing. So 36 minus 36, here also it will become the 10. Okay, anyhow it is the not 0 this activity. And another activity is the 6 to 7, that is the 40 minus 40, it is the 0. Now the critical activities are 1 to 2, 2 to 3, 3 to 4, 4 to 6 and 6 to 7. These activities are in the critical path. So now the critical path will become the 1, 2, 3, 4, 6, 7. Then we have to identify these critical path. So in the network diagram by indicating the double arrows. So our critical path is the 1 to 2, 2 to 3 and 3 to 4 and 4 to 6 and 6 to 7. So this is the critical activities and critical path is the 1, 2, 3, 4, 6 and 7. And next finally I have to calculate the total project duration. Total project duration, it will give the time duration for the critical activities. For the time duration for the critical 1 to 2 is the 15 and 2 to 3 it is the 3 and 3 to 4 it is the 8 and 4 to 6 it is the 14 and 6 to 7 it is the 14. Then so total project duration it will become the summation of 15 plus 3 plus 8 plus 14 plus 14. It will come the 54 days. So this is the solution and thank you.